With the z-score formula shown on the slide, it's possible to use a z-score to describe the position of any specific sample within the distribution of sample means. The z-score tells exactly where a specific sample is located in relation to all the other possible samples that could have been obtained. The z-score for each sample mean can be computed by using the standard z-score formula with a few minor changes. First, the value we are locating is a sample mean rather than a score, so the formula uses m in the place of x. Second, the standard deviation of this distribution is measured by the standard error, so the formula uses the standard error of m, SEM, in the place of the population standard deviation. The resulting formula, giving the z-score value corresponding to any sample, is shown on the slide. Every mean has a z-score that describes its position in the distribution of sample means. Using z-scores and the unit normal table, it's possible to find the probability, proportion, or percentage associated with any specific sample mean. The standard error of m, or SEM, is a numerical index of the extent to which means vary from one sample to another, presumably because of error associated with sampling. More generally, the standard error of the mean is an index of the amount of error that results when a single sample mean is used to estimate the population mean. That is, it is an index of sampling error. The mean of samples all drawn from the same population of raw scores vary in value, and their standard deviation, the standard error, reflects the extent of that variation, which is caused by sampling error. The natural differences that exist between samples and populations introduce a certain amount of uncertainty and error into the inferential processes. For example, there is always a margin of error that must be considered whenever a researcher uses a sample mean as the basis for drawing a conclusion about a population mean. In each case, the distribution of sample means and the standard error will be critical elements in the inferential process.